All right. So let's take a look here, right? So as I said, you don't have to write all this. I already sent the slides there, right? You can just write the important stuff that you think you might need. Okay. So for vectors, we need to remember that we can represent a vector by writing x and y vertically, or write a direction vector. So this x has a direction vector I, and this y value has a direction vector j. What's a direction vector? Well, a direction vector is basically a unit vector in the direction given. So I is in the direction x, and it's a unit vector telling you that you're moving in the x direction. What's a unit vector again? A vector whose magnitude is 1. Okay? All right, so that was the form 5 part of it, right? Where everything was in 2 dimensions. Now we should reach everything is in 3 dimensions. So all we did is we just add on, instead of an x and y value, we add on an x plane. Right? So a point here, a point in here will have an x, a y, and a z. Okay? So for example, that point P has an x, a y, and a j, and the corresponding unit vectors are I, j, k. K represents the z direction, j, y, I, x. Okay with that? Right? Our unit vector, and I write in green just to remind you, unit vector is a magnitude of 1. Please remember, if you have OP, then PO is what? PO is what? Opposite, but change the signs, right? Change the signs. It passes opposite. Pass. All right. Next, how you find the magnitude? Square root of x squared plus y squared plus z squared. If you know you never saw that in your life before, write it down. Might be that. Right? So if A is a unit vector, how do we find unit vectors? Probably write this one down. To find a unit vector, you take the vector and divide it by its magnitude. All right? Take the vector and divide by its magnitude. That's how you find a unit vector. And remember, its magnitude is always 1. Okay, nice. So please remember that I, J, and K, just make a quick note there. I, J, and K, their magnitudes are 1. Why again? Timothy? Why are the magnitudes of I, J, and K 1? Because it's a unit vector. Very good. Thanks for listening. Camera. Nikolai or Nikolai? Huh? All right, so some things for us to remember, right? Next, equality of vectors. How do you know if 2 vectors are equal? Well, if I told you A and B equal, whatever in front of I should be equal. Whatever in front of J should be equal. Whatever in front of K should be equal. Okay? That's the only way 2 vectors should be equal, right? Coefficients of all the unit vectors should be the same. Corresponding unit vectors should be the same. Any questions online? Emily? Are you okay there? Brittany? Brittany, you're listening, right? All right, nice. So that's just to show you how to compare them, right? A and D and B and E and C and F should be equal. Okay. How you add vectors? Add the x, add the y, add the g. That's okay. Remember, addition and subtraction of vectors will give you back a vector. Don't forget that. So add the x, you'll get 7. Add the y's, you'll get g. Add the z's, you'll get next value. Right? Nothing too difficult there, right? Subtraction, same thing. Subtract the x, y, and the z. All right? Here we have a quick example. Let's try it now. A is this, B is this, and C. Let's see if we can find C. Do it mentally. Go write that down. Do that mentally. So what you get? What is C? Remember, A is 3, 0, minus 1. B is what? B is what? Not C, B. B is 2. So add it and you will get C. How much is that? 5.
6 minus 1.
Very good. Right? 5 minus 6 minus 1. Okay. Next, how you multiply? Right? But if you have to multiply by a scalar, you multiply it by each one of these. So KA will be KX, KY, KZ. But when you multiply it 2 vectors, you get your dot product. And I want you to remember this. Alright, I'm going to show you the long way here. Watch this here. If you have to multiply A by B, you're multiplying AI by DI. That will give you ADII. Right? A quick question. Anybody remember? I and I are parallel, right? When you multiply 2 parallel vectors, what you'll get? When you multiply 2 parallel vectors, you end up with the magnitude of the vectors. So the answer will be 1. So I by I is 1, J by J is 1, K by K is 1. But I and J are what? I and J are what? Perpendicular. X and Y perpendicular, right? So therefore their dot product is, alright, dot product is what? 2 perpendicular vectors. I have 2 perpendicular vectors. If the product is 0. Okay? So if you look at multiplication here, I by J is 0, I by K is 0, I by I is 1, J by J is 1, K by K is 1. Alright? Finish? So in short, you multiply the i's, you multiply the j's, and you multiply the k's. And then add up the answer. Okay? Notice it is no longer a vector. It is now a scalar. That's okay? I feel like that's not okay. So let's just try one. Let's try this here. I'm trying to multiply these 2 vectors. So if you're multiplying these 2 vectors, 2 by 1, 0 by minus 6, minus 4, 2, you multiply the x by the x, multiply the y by the y, multiply the j by the j. Then add it up. It is no longer vector. It is now a scalar. Enough? Alright? Follow everything else so far? Let's multiply. Dot product we should multiply 2 vectors. Dot, yes, you're in the product. Oh wait, you answered everything else. 4? Yeah. What's the answer for B by A? Shivish. Got in your head. Fast. Time out. Same thing? Once again. So it means that multiplication is what? Commutation. Right? And you have your I by J, J by K, I by K is 0. Any questions online? Samira? NIT? Nikolai? You good there? Nikolai, you listening? You can use your audio, you know. All right, nice. All right, so I gave you the little rule to remind you that I by J, J by K, I by K is 0, right? Because the vector is perpendicular. Next, displacement vectors. Right? Displacement vectors is where you have to find the alternate route for unknown vector. All right? So if you look here, how do we find AB? How do we find A to B? Look at the triangle and find the alternate route from A to B. So you start at A, you go to O, start at O, go to B. So it's A to O plus O to B. Then add it up. Remember the line on top shows us a vector, right? Remember that? Zero? Remember that? Right? How would you find, let's say C is a middle. Here's half and half. How you find it? OC. OC is what? Right? Draw a line from. So you can find O to A plus A to C. Or it could be O to B plus B to C. Anyone can do it. Right? No. To get OC. So yes, but you'll do that to get AC. All right, so nice. There's some things for you to remember, right? Again, everything is going to be in 3 dimensions. All right. Quick rules. Write this one down because we can do a few like this. Right? How do you find the angle between two vectors? Right? You multiply A by B and then divide by their magnitude and then find cos inverse. Okay? Write this down. Some questions make you do it the long way. Actually make you do the whole thing. So write it down fast. Think the question I gave you had that. Probably the formula David fits with ing. But that's the formula for multiplication. What you probably do is you probably then replace everything. a proof. Yeah. I never proved it up. All right, and if theta is right, if theta is 90, then the perpendicular, so the dot product is 0. You all seen why? You all seen why? How come Azaria? What why? Cos 90 is what? 90 is 1. Cos 90 is 0. Cos 90 is 0, so it means the numerator is 0. Right? And if theta is 0, then the vectors are set to parallel. Right? Then the vectors are parallel. And it means that the dot product is equal to product of the magnitude. Okay? And the next thing in red there, parallel vectors are multiples of each other. Parallel vectors are the multiples of each other. All right? So that is the foundation of vectors that we're supposed to have an idea of something from form 5. So we're going to do a couple of these just to refresh ourselves, and then we are going to target the new stuff. So this might be something new, but parallel vectors, they are multiples of each other, or the dot product is equal to the product of the magnitude. All right? That's okay? All right, well, let's jump into it one time. All right, so here we have two vectors. To my favor, find the angle between them. Let's see if we get the same answer. Write down U and B, and let's see if we get the same answer for the angle between them. Was that given? No. Look it out some more again, and then let's take a look at the past table. What we got?
0.95.
All right, let's see. Let's see what we got there, right? So when you multiply, the dot product was 9, the magnitude was root 14 and root 13. When you work it out, you end up with 64. Altogether, in degrees, sorry, it was in degrees, right? Maybe in radians, I got 1 point something. Right? Any questions online? Have you seen anybody online got it? 64, 64, 70. Right? Can't round up too much, right, Nikolai? Right? Can't round up too much, right? So we use these exact values, right? Right? Here's the same thing. Let's try this one here. Right, have fun. I think it's 20. I'll look for that one. I can't give my passport book. Try this one here. Please remember, just in case you all forgot that, right? How to turn this into a position factor? Right. OP is equal to 3 minus 2, 1. Okay? 3 minus 2, 1. Right? So I like to work it out like this first and then write it like this. Okay? Oh yeah, that, and I forgot the arrow. The arrow shows up the factor, right? Go ahead. Who got this? You can do all this sketch to figure out where PQ is, right? I get you. Now, let's see how it went. I'll do time code, right? Hold on, let's find my question. Where should I take it in the group? All right, nice. So they gave us here, they gave us OP. OP was 3 minus 2, 1. OQ minus 1 lambda 5. And OR was 2, 1 minus 4. They want us to find PQ, right? They want us to find PQ. So if you want to take a set up a little diagram, it doesn't have to be perfect, right? Here's P, here's Q, here's R. Right? Let's pretend that's R, right? Mightn't be accurate, but just to show you that PQ, P to Q is P to O, O to Q. Right? P to O, right? P to O is -3, +2, -1. O to Q is -1, lambda 5. Do we have to find for lambda?
Yeah.
Now see that second part? Oh, second part. So when you work this out, you'll end up with -4, 2 plus lambda 4. But they want the answer in the next form. So that will be -4i plus open brackets 2 plus lambda j plus 4k. Right? That is your PQ. What they want after, they want QR. Same principle, Q to O, O to R. So that'll be 1 minus lambda minus 5 plus R. R is 2, 1 minus 4. Right? So we're going to get what? 1 plus 2 is 3i plus 1 minus lambda j minus 9k. Y'all got that? And then last one is what? Last one was RP. RP. So that'll be R to O plus O to P. R to O, that would have been -2 -1, 4. OP, that would have been 3 -2, 1. When you add it up, you'll get I minus 3J minus 3J plus 5K. Online? All okay there? Everybody okay with this? Huh? Online? Are you okay there, Emily? Are you okay with this? Right? What's the next part? Right. So now they said that the triangle, P, Q, oh no, QR is a right angle with side PQ being the hypotenuse. They want us to find lambda. So what does this say? This says that PR and RQ are what? Right? So PR is perpendicular to RQ. So again, if two vectors are perpendicular, then their dot product is 0. So let's go to PR. PR was sorry, RP. Right. Actually, I should have written it like this. RQ RP dot product is 0. Okay. RQ RP. The vector is at R. Okay. So I should have written it like that. RQ RP. So RP, we have it there. 1 minus 3, 5. RQ is here. So this is QR, right? This is QR. So RQ will be -3. A change in the signs here. So that will be lambda -1 -9 becomes +9. Yeah. See now? So therefore, this by this is equal to 0. So I can work it out now. -3 by this, 5 by 9 is equal to 0. Multiply it out, you'll get -3 lambda plus 3 plus 45 is 0. Do your thing can cancel off there and you'll get -3 lambda is -45 lambda is 15? No, -15. How much? -15? Plus 15, right? This is minus, this is plus. Yeah, plus 15. Yeah. Okay, so this was important so you know which one to multiply, right? All right, so this is a kind of full review of everything you would have done in Form 5. Right? Now we want to focus on the new part of the factor. Could you also use So could you also use Pythagoras theorem? You went and worked out your system?
Yeah.
You find the length? Yeah, it should work. Something. much you get 45? Yeah, so much we didn't multiply it. No problem. So that's actually good. You probably reach it. You probably reach it. Check back somewhere here. All right, nice. Any questions online? All right. So what we've been doing all the time, right? We have been finding the location of a point. So all the time, we have been taking a point, right? And giving it the vector of that point. So to locate this point, you have the x, y, and z value. And to obtain the vector, we drew it relative to the origin. All right. Now we are going to combine a whole set of points that give us a what? If you combine a whole set of points, you'll get a line. Right? So we're going to try to figure out now how to get the direction vector of a line. How to get the vector of a line. Okay, finish? So everything here that we've been doing, we have been doing it for points. Now we're going to try to get it for a line. All we need are two things. By the way, how do you find the equation of a line? Y is mx plus c. So to find a line, what you need? You need to know how much its slope and the y-intercept, right? So you need those two important things. Something to tell you direction and something to tell you the exact location. That make sense? We do the same thing with a vector. We need something to tell us the direction and something to tell us an exact location. Right? So the equation of a line are two important things. I want you to remember it like that, right? So you don't go and try to memorize the Cartesian equation or the vector form. Try to remember what you need to get, right? All you have to get is a point on the line and a direction vector. The direction vector is a vector parallel to it, right? So if the point on the line is P, the vector equation of a line is simply the point plus the direction vector by some constant. This constant is because parallel vectors are multiples of each other. That's okay? So once you have a point on the line and a vector parallel to it, you have the equation, Shivish. Yeah? What are the two things you need, Shivish? Pay attention. That's what I'm picking up. Because you're zooming out. Like the whole class. Right? The two things that you need to get the vector equation of a line is the point on the line and a vector parallel to it. All right? All right, so head up vector equation of a line. Real easy, a real nice topic. Vectors technically come really easy. I haven't really seen a hard vector question in a past paper. I don't mean in your year it might be a hard one, but generally, right? Generally they come finally. All right. So the first part of the note, I just want to get a diagram and I'll explain everything, right? So we are trying to get the vector equation of the blue line. This is not, I didn't spend this. It's not on your phone, Chivish. So you know how to just draw the diagram and I want to explain how we get the vector equation of the line. Yeah, draw the diagram. Right? Vector equation of a line. So we try to get the vector equation of the blue line. Right? We have the vector parallel is B. And we have some random point on it. Catch that quick? Aaron will help us do this. Are you ready? So we would like to get now the vector equation of that line, right? Remember I told you P is a parallel vector, right? So let's start. So I gave you a point on the line A and I gave you some moving or some random point R, right? What's AR? AR is what? You're using displacement vector. AR is what? I like to use the minus, okay. So AR will be AO plus OR. Same thing, right? Which is small a plus, right? So I'll just kind of specify here everything that you need, right? So AR is AO plus OR. AO is minus A plus R, and then B is a parallel vector to AR. So you can combine it and find for R. Right? Yes, that didn't make any sense, but just here. Right? This is the vector that we're trying to get. This is the question. Right. This is the line that we're trying to get the vector equation of. Okay, we're trying to get the equation of this line. So in order to get it, we need two things. We need a vector parallel to this line. Let's call that vector B. We need a point on the line. Let's call it A. If we have a point, we can find the position vector, small a. Remember that? And then the equation will be in terms of R. R is technically any point on this line, right? R is any point on this line. So the position vector of R will be small r. So how am I going to get the equation of the line? To get the equation of the line, we said AR is A to O plus O to R. A to O is minus A because we're going against the arrow. O to R is the vector R there. Are you okay with that? But remember, AR is parallel to B, correct? And parallel vectors are what? Parallel vectors are multiples of each other, correct? Yeah. So therefore, AR is some multiple of P. So let's call the multiple lambda. That's okay? So it means that we could easily find for R. R is equal to lambda B plus P. Well, pointers come first, right? A plus lambda B. Right? That is your vector equation of a line. Okay? Right? Now we're going to take it from here now and give you all the other forms. This is vector form. I'm going to give it Cartesian form and I'm going to give it the parametric form. Okay with that? So what do we need? Two important things. A point on the line and the vector parallel called the direction vector. Right? Copy this. Right? Actually prefer you copy this one, right? Hold on. I just do kind of talk in there. This one have the token written down. Right, that please. I want to send you all these slides, but I know some of them might never open that up again. If you write it, at least I'll make you write it once in a while. Huh? I'm not write it. Well, if you write it, I'll send it next week. But write this in the meantime. I've got questions on this now. Right? Right now the unit, the module 300, $10 that if it go up, then I'll make what it's paid for. Right? Anybody miss it? Anybody miss it? Should be you before. Anybody online wants follow again? All right, Nicola, I know here. That's 12. Huh? Hmm? Anybody online want a copy of the module 3 handout? It shows about 20 pages. All right. But I could also send a PDF for those who are online, right? If you want to print it, just not much pages. I'll see you on the right now. All right, so when you finish here, I will do it. I will send something on the group, right? And now you just answer if you want PDF or what, and you can just pass it the office and pick it up. The one for the crash course, though, you might have to pay for that because that's much bigger. Maybe I put up 40, that's it. Just to have somebody reliable to print. That's the problem. This one I did right here because it's small. All right, anybody write pencil? So, want to take a look at the how to get the other forms, right? The form that we see in there on the board is the vector form. So you want to get the Cartesian form. The Cartesian form will just be x and y, and the parametric form will be in terms of the variables. All right, I just want to show you what we're trying to achieve. That there is what we're trying to achieve. That is the parametric form, x, y, z, in terms of some variable lambda, right? And then this here is this is the Cartesian form where it has no lambda. Okay, it only has x and, well, whatever the points are. All right, so we're trying to achieve that. Okay, so first thing first, we said that R was any point on the plane. So R is x, y, z. Right? Any point on the plane. We said that A was some random point. So let's call the point A, B, C. Okay with that? Right? And then actually let me call the vector equation of the plane. Let's call that A, B. I used B already, sorry. Let's call it alpha, beta, gamma. Let's call here x1 because it's one of these, right? X1, Y1, C1. All right? So we're going to get parametric form first. Parametric form is where we're going to write x, y, and z in terms of some variable. All right? Real simple. X, Y, Z is equal to x1, so I'm multiplying out this. Right? So I'm multiplying this out, alpha lambda, beta lambda, gamma lambda. Right? And then we're going to add everything up. So you'll get x, y, z is equal to, add everything up. X1 plus alpha lambda. Brittany, there still? Brittany? Y1 plus this. And z1 plus this. That's okay? Are you okay with that? This is your parametric form, right? X in terms of this, y in terms of this, z in terms of this. So x is equal to x1 plus alpha lambda, y is equal to y1 beta lambda, z is equal to z1 plus gamma. All right? Yeah, Shabish? Yeah? Try to focus. Well, okay with this? Right? Let's put some numbers into it real fast. Well, okay with this? Right? So let's put some numbers into this. If we had 2, 1, 4, 0, minus 1, 3, right? If we had these numbers, then the parametric will simply be what? Shavish, what would it be? What would it be? What would it be? 2 plus 0 lambda, 1 minus lambda, 4 plus 3 lambda. That's it. That's okay? This is your parametric. X, Y, and Z in terms of lambda. That's okay? Shabish, how I get this again? What is? Add the X, right? Then add the Y. Right, so as I said, this is your Cartesian form. How do I get the Cartesian form? It's the parametric form, sorry. Right? Right? So, all right? Parametric form. Right. How do I now get the Cartesian form? The Cartesian form has no lambda. What would I do? Divide now. Can divide by lambda? Also, your lambda there. What we can do? How we can remove lambda? Can I make lambda the subject everywhere? if I make lambda the subject here, what will I get? X minus x1 over alpha. X minus x1 over alpha. If I make lambda the subject here, what will I get? Make lambda the subject here for me. Pardon me? I'm making this subject as the formula. Sorry? You're moving across the y1 first, huh? So what you'll get? Y minus y1 and then what? Over? Over. Alright, redeem yourself here. Redeem yourself here. What would it be? Come on. Alright. So now that we know what lambda is, we can say, we can equate them, and they're all equal to lambda. So we will get x minus x1 over alpha, y minus y1 over beta is equal to z minus z1 over gamma. This here is your Cartesian. That's it. See how easy? Do that mentally from a past area. What's the Cartesian of the example I gave you? Make lambda the subject here. X minus 2 over 0. Well, that don't make no sense. Huh? But next one is what? Minus 1. And then what? Yeah, z minus 4 over. Right? So this is what your Cartesian form will look like. That's okay? Yeah? Aaron? Copy it down quick. And then finish squeezing one more in your mouth. Right? So we have to be able to go from one form to the next. How do you remember? Cartesian form has no lambda. So you have to make lambda the subject and equate. Parametric form has lambda. So you have to make x, y, and z subject. And vector form is the next one. So you have to remember each one of these forms, right? Right? So I like to start in the same order. It's kind of easy to remember. Start with the vector, make x the subject, then make lambda the subject. Right? So write that little summary down, right, Shivish? Start with the vector. Then make x the subject to give you the parametric, then make lambda the subject to give you the Cartesian. Start with the vector. Then make x, y, and z the subject to get the parametric. Then make lambda the subject. Huh?
After making a subject.
Then that'll give you the Cartesian. All right, one for the roadie and we done. Find the vector equation of the line there. All three forms. Oh yeah, find the vector equation of the line. All three forms. Pardon me? Oh yeah, do that fast. Should be you only have 5 minutes. Also one note. Oh yeah, work it out. Just skip out all this shit. You know you like to write this long thing and then do finish.
Yes.
Write it underneath part and let's work it out for me. Ignore that part on top. Look at there, write it for you. This is still trying to see. Right, find all three forms. That'll take you 2 minutes. Right, let me see who online who not paying attention. Let me see who I can pick on. Keelan probably not paying attention. Brittany not paying attention. Huh? Who? Ryan. Devish. Send your answer, please. It's Caleb. No, she's Caleb. Find all three forms, right? Maybe she need to pen to write on the answer. But what's on the board here still? Let's substitute the numbers and add on. earlier. If it had a match tournament online, are we gonna do it? No, are we gonna do it? It's keep, just keep. Are we gonna do it? Keep. 1, 2, and 3. When something, if I win a trip that yeah, I win something like that. And it's like 5 less time. Right, but you have a time limit per question. Or we cannot show in the answer chat. Yeah. You want to show you. Right, Shivish, what to do? Right, so first thing first, we have vector form. Everybody okay with that? Remember, B was, you have to put the right thing for A and B, right? According to the information here, B was the parallel vector there. So that's the reason why I put B here, right? And A is the point. So A goes here, B goes here, and all it will finish. Okay, John? You okay with that? So you write it vertically first, and then you make, and then you multiply it out. Right? And you end up with x is equal to 2 plus 2 lambda, 1 plus lambda, minus 3 minus lambda. Look at that? Parametric. And then, what's the next step, Shivish? To get Cartesian? Make lambda the subject. When you make lambda the subject, you will end up with x minus 2 on 2, y minus 1 on 1, minus 3 minus 0 on 1. Okay? And you go through. All right? So next day we will take a look at how to determine if a line is parallel, how to determine if a line intersects, or if not, how to determine if a line is skewed. All right? So we're going to finish up this module next day, and we'll do back the equation of our plane. And then we'll do our test. Cool.